Okay, now let's go back to an example that we want to calculate areas. The function that we have now is the absolute value of x minus 4. And we're looking to find the area between that function, the x-axis, and x equals 0 to x equals 6. Okay? Remember, in order to find areas and use the definite integral, you have to make sure that your function is positive. But of course, my function is the absolute value of x minus 4. So, of course, it's positive. Then the area is nothing more than this integral from 0 to 6, absolute value of x minus 4 dx. The problem now is, how do we find integrals of absolute value? And the answer is, we get rid of the absolute value. So just like we did in the past, you have to somehow change this absolute value of x minus 4. And absolute value of x minus 4 changes into a piecewise function as follows. It is the same thing when the quantity here is positive, and the quantity here is positive if and only if x is greater or equal to 4. And it's minus that, so minus x minus 4, if your quantity is smaller than 4, if x is smaller than 4. Okay, so we have two pieces for this function. Okay, how can we plug that into an integral? Well, what we can do is use the last property in the previous page. And instead of calculating this integral, we can start from 0 and stop it at 4. And then to that, add the rest from 0 to 6. Okay? So by using the last property, we can do that because 4 is in the middle. So we can do the integral from 0 to 4 and then from 4 to 6. And what that enables us to do is we can replace here the absolute value of x minus 4 with just x minus 4 with minus x minus 4, because in this interval the function itself is negative, so the quantity itself is negative. So the function becomes from 0 to 4 minus parentheses x minus 4 dx. And in the interval 4, 6, look up there, your absolute value becomes x minus 4, just x minus 4. Okay, so we got rid of the absolute value, and it's very easy to calculate those things. On the notes, I go into details of calculating each and every one separately. Let me also show you how to do that in one step, because now let's distribute the minus. This will give you 4 minus x dx plus 46 x minus 4 dx. I'll find the antiderivatives right away. And so the antiderivative here is 4x minus x squared over 2. And we're viewing this from 0 to 4. And the antiderivative there is x squared over 2 minus 4x from 4 to 6. Okay, and let's plug in the 4. You will get, I'm going to go up here, 4 times 4 minus 4 squared over 2 minus, so that's just the first term still, okay? So now I need to plug in 0 here, which will just give me 0 because it's 4 times 0 minus 0 squared over 2. That was the first term. And now let's go and try to figure out this guy. So plus, I need to plug in 6 here, so 6 squared over 2 minus 4 times 6. And then to that you have to subtract this term with a 4. So let's go ahead and do that. So it's 4 squared over 2 minus 4 times 4. Okay, so see how this turned out into the difference of these two, and this one turned out to the difference of this one instead. All right, let's go ahead and finish the calculations. 4 times 4 is 16 minus 8, because it's 16 over 2, that's 8. This whole term is 0. This is 36 over 2, that gives you an 18. 4 times 6 is 24, the minus. This is 4 squared, 16 again, over 2, it's 8. But there's a big minus up front, so minus 8. And then this is 16 minus 16 plus 16. Okay, now let's see what cancels here. We have the 16 with the other 16. That gives you a 32, but let's do it like this. minus 8, and the 16 go away. And then 16 plus 18, this gives you a 34. Minus 24, the answer is 10. Okay, and that's your final answer here. Answer is 10 for this guy. So let's review what we did here. We had to calculate the definite integral from 0 to 6, because that's the area. Then we had to break up the absolute value into a piecewise function, because there's no other way to calculate integrals with absolute value. And then we found the two pieces of that definite integral from 0 to 4, when x minus 4 is changing into minus x minus 4, and from 4 to 6, when the absolute value changes into just x minus 4. Okay, and then we just calculated the whole thing and added at the end.